In this video, we're going to be taking a look at kinematics in one dimension. Well, that begs the question, what are kinematics? Well, kinematics are the concepts that describe the motion of objects. So whenever we're going to be taking a look at different objects, how fast they're going, how far they're going, how long it takes to get there, this is the part of physics that we're going to use. So what things are we going to be talking about when we're describing motion? Well, we have 5 different things that we're going to use to describe the motion of any object. The first is displacement, given by the letter D, and it's measured in meters. In English units, we've been measuring this in feet or miles, but for physics, we're going to stick with meters. We have initial velocity with a V with a little 0 next to it. That's what the symbol will be when you see it in equations. That just means velocity at time 0 is pronounced V0, so the velocity at the beginning of the problem. This is measured in meters per second. Final velocity is V, the little F next to it for velocity at the final time that you're looking at this, also measured in meters per second. We have acceleration, given by the letter A, and that is measured in meters per second squared, or meters per second. We'll get into a little bit more of what that means when we get to the acceleration part of this. And then we have time, just how long it takes to get there, and we're going to measure that in seconds. So the first thing is displacement. What is the difference between displacement and distance? Because a lot of people think that they're the exact same thing, and they're close, but they're not exactly the same. So you can see this little picture here, and the green line is the distance that the red ball has gone around this track. The blue line, however, is the displacement of the little red ball. So the green, being the distance, is exactly how far it goes. If you had a pedometer on, or if you were GPSing something, that's how far you went. Displacement, on the other hand, is the blue line, how far you are from where you started. So if this thing went all the way around the track and got back to the beginning, the displacement would be 0, because you are no further from where you are than where you started. You started at the exact same spot you finished. So your displacement would be 0 if you went one lap around the track. Most of the time in kinematics, we can use distance and displacement interchangeably, because most of our problems are moving in a straight line. They either go directly to the left or right, or they go directly up or down. But it's going to be a bit of an issue when we get into some of the up and down problems if we throw something upward and it comes back. Obviously, if you throw something up, it's going to come back down. You can catch it. So the displacement, if you throw something up in the air and you catch it in your hand, is going to be 0. We'll get to that when we start doing some of those types of problems, but it's just a good idea to make sure you remember that there is a difference between distance and displacement, and we are going to be using displacement in here. Now we have velocity. Velocity is often used interchangeably with speed, but there is one big difference, and that is that direction matters. So if you're driving in your car doing 60 miles an hour, that's a speed. If you drive 60 miles an hour east, now you're talking about a velocity, because now you have a direction involved. So you can see the top picture here, the car is moving to the right, the bottom picture, the car is moving to the left. You can see a little plus sign and a little minus sign here. We typically say that things that move to the right are positive and things that move to the left are negative. So we would say that this car on the top has a positive velocity, whereas the car here at the bottom has a negative velocity. And all that would mean is that we take the number up for the speed, whether it be 1 meter per second, 2 meters per second, and up here it would be a positive 2 meters per second, and down here it would be a negative 2 meters per second. That's going to matter when we start trying to do problems. We have acceleration. Acceleration is how much faster or how much slower an object gets. As I talked about previously, it's measured in meters per second squared, or meters per second. Here's how this works. In this particular picture, you can see that the car is starting from rest and it's pulling out, and it's getting faster and faster as it does so. So if this car has an acceleration of 10 meters per second squared, or 10 meters per second, that means that the speed of the car gets faster 10 meters per second for every second that it's accelerating. So after 1 second, the car has a speed of 10 meters per second. After 2 seconds, it goes up another 10 meters per second to 20. After another second, it goes up to 30. So the speed increases by 10 meters per second for every second of the acceleration. If it was decelerating, it would still work the exact same way, and oftentimes we say decelerations are negative, and that'll make a little bit more sense when we start doing some problems. Talked a little bit about the positive and negative numbers. We're going to say that things in this class, when they move to the right or they move up, are positive things. If they move to the left or if they move down, we're going to call them negative numbers. So you want to make sure that you know which way your objects are moving before you start plugging numbers into your equations. Constant velocity, this is the very first equation that you're going to get. and it is velocity equals displacement over time, or if you rearrange that and move time over to the left side, you get displacement equals velocity multiplied by time. Here's how this works. If you're driving in your car and you're doing 60 miles an hour, you know how fast you're going. Now, in this class, we're going to be worried about, are we moving to the left or to the right? In this case, this car is moving to the left, so we'd say it has a negative velocity. So it might be a negative 60 miles per hour. Now, how do we figure that out? If we know the distance that this car travels from this side to that side, and we know how long it takes to get there, we just divide the two numbers, and that's how fast the car is going. This equation only works for objects that are moving at a constant speed. So if it's getting faster or getting slower, we can't use this one. We're going to be taking a look at some other equations later that'll help us with things that accelerate. Relative velocity. It's important to know that velocity is based off of a reference point. So in this particular picture, initially it just looked like somebody was sitting in a room. They're not moving at all. Their chair's not moving. Their book's not moving. But when they open the window, you can see that they're actually on a train. And they're moving quite quickly because you can see the trees going by. So before you open this little window, if I were to say, hey, how fast is this guy moving? How fast is the book moving? How fast is the chair moving? You would have said it's not moving at all. It's not moving compared to each other. He's not moving compared to the book because he's holding the book. But once you open the window, you realize he actually is moving. He's moving relative to the trees because he's on a train and he is moving. So remember, when we talk about velocity, it's always based off of something else. So how fast is something moving? It's how much faster or slower it's moving compared to something else that you want to talk about. And typically we want to say how fast something's moving compared to what we call stationary objects, a tree that's on the side of the road. We know that's not moving. Just remember that all velocities are based off of something else. So that's why it's relative. Your velocity is dependent on what you're going to describe it against. Now, I talked about equations for when objects are accelerating, and these are the equations that we're going to be using. And this handy little chart tells you what variables are in each equation. So if you take a look at this first one, it's got final velocity equals initial velocity plus acceleration multiplied by time. It's got all the variables that have the green checks, and it's missing the displacement variable. Notice this one's missing displacement, the second one's missing acceleration, this last one's missing final velocity, and this last one's missing time. They all have initial speed or velocity in them. All you need to do, and you can take a look at the videos that talk about how to solve kinematics problems, and that will help you out quite a bit. But what you really want to make sure you do when you read a problem is write down all the information that's given in the problem. Are you given initial velocity? Great, write that down. If you're given acceleration, time, displacement, or final velocity, you want to write all of those down. Once you know what variables you have to work with, you can then come back to this chart and pick which equation you want to use in order to solve for whatever it is you're looking for. And the final part of kinematics is free fall motion. So objects that get thrown up in the air or fall down. Even if you throw something in the air, it's still technically in free fall. It's moving upward, but the only force acting on it is gravity. And if gravity is the only force acting on something, then that is going to be a free fall motion. Free fall motion, by definition, is when an object is in midair and the only thing acting on it is gravity pulling it straight back down toward the earth. So skydivers, a baseball that gets thrown up in the air, this is going to be a little bit different than projectile. So if you throw a football to a friend who's 10 meters away from you, that's projectile motion, not free fall motion. Free fall is just straight up and down. And that's the end of kinematics. Those are all the concepts that we're going to be talking about. Please make sure you check out the other videos on how to solve actual problems with kinematics.